In this section, I'm going to talk to you about BGP validation. We went through a process where we pushed BGP configurations to both an Arista, or actually to a couple of Arista switches, and to PyNet router 1. And let's go ahead and redeploy those. And let me just make sure the config's actually being deployed so that we're doing a commit. We are committing our changes. Go ahead and redeploy those changes. Now, let's start talking about how do we validate that the operational state has achieved the end that we intended. So we want at the end of this to have a BGP peer up between PyNet switch 6 and PyNet router 1, and also a BGP peer between PyNet switch 5 and PyNet router 1. And we also have a couple of prefixes that we're announcing. So we have two prefixes we're announcing from PyNet router 1, and one prefix we're announcing from PyNet switch 5 and PyNet switch 6. And if we go ahead and look at our host vars PyNet switch 5, you can see here's our peer. We want to peer to PyNet router 1. Here's the route we want to announce. Similarly, for PyNet switch 6, very similar configuration. We're peering to PyNet router 1. We're announcing this time 2.2.3.0/24. And PyNet router 1, we have these two peers that we're peering with, and here's the two routes that we're announcing. Now, if we go and look at our current config, or our current operational state, so we look on PyNet router 1 and see what our current operational state is. Okay, so we actually, with PyNet router 1, yes, we have a peer, a BGP peering session established to Arista switch 5, Arista switch 6. We're learning a prefix from them, but we also have this other peering session. In this case, this is with an iOS XR router that's not supposed to be there. Similarly, if we look at Arista, let's see what we have in the Arista case. Okay, so PyNet switch 5, we have a peering session established with PyNet router 1. It's up. We're learning two routes from them. Here we have PyNet switch 6. It's up, and we're learning two routes from that peer. So we want to add verification that our peering session is correct. Now let's start looking at how we do that. Now I've already pre-created this because it was starting to get prohibitively hard to try to do it on the fly. So let's walk through this process and look at what we have here. Okay, so here we're configuring our BGP just like we did before. Now I've actually added a step here, and that step is actually to remove the files from the configs directory. So here I'm removing the files. Oh, that's the wrong playbook. Let me go ahead and remove those comments. I actually want to look at we did that in the previous BGP section. I want to look at the BGP validate section. And let's look at what I have here. Okay, so testing connectivity with Napalm. I'm retrieving BGP get facts with Napalm. So I'm just doing a get BGP neighbors. And then let's look at what I have at the end of this task 2. So let's look at what I get back at this point. Go ahead and run my playbook. Now, how did I choose to use Napalm in this case as opposed to using Ansible core modules? in this case, I knew that napalm had a something that did a basically get BGP neighbors and would retrieve the neighbors. And here we're trying to validate that the set of BGP neighbors matches what it should be. So I knew that napalm had that, and I know napalm returns me structured data. If I would have used the Ansible core modules, I could have tried to retrieve it for the Arista switches, which will get me back structured data. I could have tried to do it for iOS, but then I would have to somehow get structured data back. And the thing that immediately comes to mind for how I could get structured data back is there's something called NTC Ansible, which has a templates associated with it. Those templates allow you to convert from unstructured text to structured data, and there's a couple ways we could have done that. So I probably would have tried to go down that route if I would have stayed with the Ansible core modules. But I know here that I have in Napalm, I have a getter that lets me retrieve them. So let me try to use that for both Cisco and for Arista. Okay, so now we'll get down here to where we're retrieving our get facts. And let's see what we get back here. Scroll up. Here's my variable I get back, this napalm get neighbors. Here's my VRF, which is going to, for the default VRF, be global. Here's my peers. So I have a 10-20 peer, this 88.32, here's 88.33, which is PyNet Switch 6, and here's the one that's not supposed to be here. And I could scroll up and I could actually see similar data for, in this case, Arista Switch 5. Here's my 88.20 peer. So now I need to take this output and I need to retrieve only the things I want. And let's look at that process. So here's the output data structure I'm getting back. So a lot of times the pattern I'll do here is I'll use the debug and I'll just do the message statement with it. So I know that I want this variable. Inside that variable, I know I want this key, the global key, because in this example, we're only worrying about the default VRF. And then if I scroll down more, I know I want the peers key. So we have this sequence of keys. Here's my main variable, the global key, the peers key. And now I need to comment this out because 18 through 23 are not valid YAML. So I comment out what that structure looks like. Now I replay my playbook. This time, since the debugging prints it to the screen, I do not need the VVV flag. Okay, so we're executing. We're verifying our BGP. Now, here we have a simplified data structure. So we've peeled back a couple of layers. Now, I want to verify the peers. So at this point, I'm just trying to verify, are the peers, do they match the ones they're supposed to match? You could sort of add a follow-on step where you want to verify that we've reached the established state, which in napalm should be this is up. But here, we're just trying to verify, do the peers specified in my operational state, do they match what's supposed to be configured? So that would be this key, and this key. Now, we have this question of, well, how do I achieve that? I know Ansible has this thing called with_dict that lets me iterate over a dictionary. So let's try to use that. So we'll go to our debug statement, we'll copy this line. Now here we're going to do with items. Now I'm going to actually do another technique here, which is a very common pattern. I'm going to save what I did above as a new variable. So I'll say set fact, and I'll call this BGP neighbors. So whatever the output of this was, I'm going to save that as a new variable. It's going to be my BGP neighbors. Actually, let me call it BGP. So it's the operational neighbors, i.e. the one that we're getting back from our show commands. Now I'm going to go down here to with items, and actually not with items, with dictionary. What am I going to do with dictionary? I'm immediately going to loop over this variable I just saved here. And then this is not going to be just straight message. It's going to be message item. Item is going to be what this with dictionary gives back to me. In fact, there's going to be an item.key and an item.value. But right now we'll just look at the whole thing given back. Go ahead and run our playbook again and see if we've made progress. So testing connectivity, we can probably get rid of that at this point because we know our connectivity is working right. Now, this gets a little bit confusing, but here's our item coming back. It's getting printed out in the message. The item has a key called key, which points to the peer IP. And then the value points to the value corresponding to that key. So this is a byproduct of that with dictionary that we're doing. All we want is this. All we want is the peer IP. Go back here, so we'll do not just straight item, but we'll do item.key. Just give me the keys of this thing we created here. That's all I want, is the keys of this thing. Go ahead and re-execute our playbook. Next time I'm going to try to get rid of that testing connectivity because it's just wasting time at this point. Okay, doing our show command on the 3 devices. Okay, we have that back. Now, this gets a little bit confusing because of how Ansible does the output. So here's our OK statement. Here Ansible actually prints out the full item. I don't really like this behavior, but that's what Ansible does. But here's our message statement. Our message statement has each one of our peers. So here's this peer, here's this peer, here's this peer. Now, we need to make a list from this. We need to make a list and not just this separate string each time we go through. So how do we do the list creation? This is actually a little bit of a tricky technique as well. So the first thing I'm going to do is create a blank dictionary. And I'll call this BGP, whoops. So once again, we're still on our operational, BGP operational neighbors. And I'll give it some other name like BGP current neighbors. I want this to default to a blank dictionary. Not a blank dictionary, a blank list, excuse me. Okay, so if I just do that, I have a blank list. Then I'm going to do an append statement, and I'm going to append item.key to it. Okay, so this is complicated. What the heck am I doing here? So here, I'm just looping over this variable that we created here. What is the variable that we created here? It is a dictionary, where the only thing we care about in that dictionary is the keys. Now I'm trying to convert these dictionary keys over into a list. In Python, I would just do this by doing a literal call on BGP op neighbors dot keys. Give me the keys back. So I'm trying to do the equivalent of that in Ansible. There are several ways we could solve this. One of the ways we can solve this is by using this with dictionary, looping over them. Each time through, I'm going to basically be appending to a list. Here I just start out by making my list be a blank list, and then each time through, I add on to that list my new peer. So at the end of this, hopefully for each device, I should have all my peers. And I forgot to comment this out. So we'll go ahead and save that, run our playbook. So we're running our show command to Arista switches. And then the last one was the router. Now notice what I get back for message. This device has a list with a single element, just router 1. That was PyNet switch 6. Once again, a list with a single element. That was PyNet switch 5. Now we go back here. Now we have a problem. Here we have a list with a single element, and it is 88.38. That's not what I wanted. I wanted a list with all the elements, not a list with a single elements. Now let's go back and look at my playbook. So BGP current neighbors each time through is being set to a blank list. So now what I'm going to do is switch this debug to not be just a debug statement. Instead, I'm going to make it be a set fact, and I'm going to make this be the variable BGP current neighbors. So each time through the loop, BGP current neighbors is going to get set to whatever the current value of BGP current neighbors is plus this. And then there's a one little caveat. If this is currently undefined, it gets set to a blank list. Let's try to execute that playbook, and I'll actually need to execute it with VVV and see where we are at. So once again, we're going through this process of we're trying to verify the neighbors that we intended to configure with what's there on the devices, in this case the 3 devices. Okay, so BGP current neighbors is that. BGP current neighbors is that. Get up to PyNet router 1, and I still have a problem. So in the next video, we'll work through this issue of what's going wrong with my setFac operation. How do I convert it into a format where I'm getting all of the devices as opposed to just getting one of the devices in my list creation?